next week, you guys, on Tuesday and Thursday, we'll be taking the CRT test for this class, the end of level, okay? Tuesday and Thursday. I told you we will study for the test about the first 20 minutes before we take it, and then we'll go in and take it. Okay, and then also on Thursday we'll study for the first 20 minutes beforehand, and then we'll go in and take it. Okay, so plan on that on Tuesday and Thursday. All of you need to take the CRT test since you're enrolled in geometry, and you'll need to take that test. And you need to do your best on it. I'll tell you what, I'm going to make you a deal. If there's 70 questions on the test, and we'll be able to pull up the day after you finish the test on Thursday. So on Friday, so by the following Monday I should have them, no problem. If you get a raw score of 47, well, I'm going to say 48. 48 out of 70 or higher, that means you will, usually the cut score is around 48. That means you will pass the CRT with a 3 or a 4 if you get 48 or higher. Okay, so if you can score that, then you're doing really well, and you'll get a score of that. But what I was going to say is what I'll do for you, because I'm going to put this on your grade for this quarter. I will put this on your grade for this quarter. If you score a 48 or higher, a 48 is 100%. So anything above that is extra credit on the test. So you can really help your grade out and boost it up if you do better than that. I've had students in my past geometry classes that have gotten 100% on this test before. Okay, a few people. But usually the best students usually will still miss 3 or 4 because it just makes silly errors. But you should get a score, a pretty good score on it. Okay, so do your best on the test next week. All right. Okay, let's talk about these 3 problems right here. Maybe I'll let you guys volunteer. Who wants to do number 1? Matt? Do you remember how to do it? Okay, do for number 1 for us. Or you can tell me. Which one do you want to do? Tangent. Tangent of 25. Okay, it's opposite over adjacent. So which one would it be? X over 14, yeah. Okay, hold on just a second. Was anybody not here last time? I'm just going to toe it down. Just so you guys remember these acronyms. Sine equals opposite over hypotenuse. That's that one. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Well, we have, from our angle, 25 degrees, we have opposite over adjacent. So we use the tangent. That's why we used it. And then, what'd you say, Matt? Times by 14? Those cancel out. And so you put in your calculator 14 times the tangent of 25. What did you get? 6.5? Okay, any questions on that one? Okay, do I have another volunteer for number 2? Yeah. Okay. Well, I knew the given angle was 25. So which side do I want to get from 25? I want to find x. Which side is that? That's the side opposite of 25, right? It's opposite of 25 degrees. And we had side 14, which is next to 25 degrees, which is, adjacent, okay? So I want to know the opposite. I have the adjacent. So I know that opposite and adjacent goes with the tangent, okay? Opposite and adjacent goes with the tangent. So that's why I use tangent. And you always do the tangent of an angle is equal to opposite, which was x, over adjacent, which was 14. Okay, Lindsay, I'm going to have you do number 2. What do you say? Okay, so she took the sine of 40 degrees. Why did you take sine? opposite, which is y, and we're given the hypotenuse. Remember, the hypotenuse is across from the right angle, 10. So y over 10. So she used sine because we had opposite and hypotenuse, guys. And then what do? Okay, times both sides by 10 and 6.4. So y equals 6.4 there. Any questions on that one? Okay. Who thinks they got the third one? Johnny, do you have the third one? Megan, you have the third one? Brooklyn, you have the third one? How about you guys? Mitchell. Is he right? Yeah. Cosine is because here's our angle that we're given, you guys, 58 degrees. Which side do I want? I have z, which is the adjacent side, and I have 12, which is the hypotenuse. Adjacent and hypotenuse. Look over here. Cosine equals adjacent over hypotenuse. So it's that one right there. Cosine of 58 equals z over 12 times both sides by 12. What did you get? 6.4? Yeah, those are all pretty close in numbers, right? Okay, that's a little review. I'm going to answer questions on the assignment from last time. What do you think? What do you have for me? We just reviewed how to do a problem if you're looking for an angle. This is cosine because you have adjacent and hypotenuse. So we did cosine of x equals 12 over 15. And you put it in your calculator as second cosine, which is cosine inverse of 12 15. So you get 36.9 degrees. Hey, also, I just was telling you guys this, but I forgot it. I wasn't recording this, so I'm going to say it again. This assignment is going to be due on Friday. I'm going to give you an extra 2 days on it, okay? So Friday, we'll turn it in. Come with it done. I expect done. How many of you have it done? Good. Good. Today, you guys, I'm going to teach you how to do equations of circles. I'm going to tell you where we're at with the learning what we need to learn this year. I needed to teach you the first 2 sections of chapter 14, and the last section of chapter 14, which is lesson 6, in order for me to have taught you everything you need to know this year, and we're not getting that far. So I'm going to teach you 14-6 today, because on Friday I want to review a little bit for the test, okay? So we're going to do lesson 14-6 today, and know how to do equation circles. The reason I'm going to do this one is because there's like 5 questions on the CRT test about how to write equations of circles. You guys want to get 5 problems right? Here's how you do it right here. Know how to do this. It's not hard, okay? So we're going to learn about writing equations of circles, okay? This is really easy stuff. If you listen, write it down. I want you to write this down and listen to it, okay? So this is the equation of a circle. X minus h squared plus y minus k squared equals r squared. That is the standard form of an equation of a circle. Okay, x minus h squared. plus y minus k squared equals r squared. Now, it seems confusing, but let me just show you a couple examples and you see it's not. But I need to say this, h comma k, whatever the numbers h and k are, that's the center of the circle. Okay? So h and k, whatever numbers are in for h and k is the center of the circle. And r is equal to the radius of the circle. R is equal to the radius of the circle. Okay, because r squared is not the diameter. 2 times r is the diameter. Okay. All right, so let me draw a picture of a circle. I was doing good till right there. Okay, pretend like that's a circle. Pretend like that's a circle. Pretend like it's a circle. But it probably wouldn't make a very good circle. Okay. Okay, I can draw pretty good circles if I don't have to get it exactly. Yeah. Right. Okay, but I had to go through those 4 points out there. Okay, where is the center of this circle? Everybody, in 15 seconds, by 15 seconds, I want you to raise your hand knowing where the center of the circle is. Everybody figure it out. What are the coordinates of the center of the circle? Where is it, Chris? Okay, and so when we say coordinates, we usually say the x number first, right? So it's going to be 5, 3. You just said it backwards. 5, 3 is the center of this circle. So that's what h and k are going to be. What is the radius of my circle? When you know that, raise your hand. Radius of the circle. That's from the center to the side. What is it, Johnny? It is 3. There's 3 units from here to there or anywhere else along the circle. So r is 3. So I have h is 5, k is 3, and the radius is 3. All I have to do to write an equation of this circle is take that formula up there. X minus what, everybody? X minus what? 5 squared plus y minus what, everybody? 3 squared equals 3 squared, which is 9. That's my equation of my circle. Could you guys do that? There are usually 2 questions on the test just like this one. Well, if you took advanced mathematics, you'd want to know how to do that. Are you going to take advanced mathematics, Matt? You got a math mind. I would have passed you. What's the equation of that circle? Well, you might be working with a circle on something, and you need to grid it out, and you need to do it. Maybe if you're doing computer programming, and you have circles on there, you need to do it, grid it out. You need to do it. Okay. So you might need to know how to do that. Okay? How many of you think you could do a problem like this again? Okay, we're going to try one. Everybody, right here. Okay, here we go. That was the answer. Wait, hold on, hold on. was getting there. Okay, write an equation for that circle right there. Give you a minute. Okay, David Sundin, where's the center of this circle? I think it's 4. Okay, negative 4 comma 4 is the center. Okay. Okay, what's the radius of the circle, David? Yep. 1, 2, 3, 4, 5, right? Okay, Megan, how do I write my equation? Write it out for us. What's the x number? Oh, did you say plus 4? Okay, I couldn't. I thought you said squared equals 25. What do you guys think? Is she right? Why do we have plus right there? Yeah, x minus a negative 4 means the same thing as x plus 4. Johnny, did you guys get that? Since that was negative 4, x minus negative 4 is positive 4, right? 5 squared is 25. Don't forget the squares up here. That's the equation of a circle. Huh? Since there's not, oh, there's x and y are our variables. It represents points out here, okay, on this thing. When you plug a number in for x, you can get a y number. So as far as what we're doing right here, that's always going to be x and that's always going to be y. All you do is plug a number in for h, a number in for k, and a number in for r. That's all you do. Okay? All right, next one. Let's see if we can do this one. Gotta admit that was pretty good right there. Okay. Find me an equation of this circle. Haley, where's the center of the circle located? Okay, good. What's the radius? 3. Okay, Kayla, what's an equation for this circle? Squared. Very good. Good job. How many of you had that? Chris, take your time away from texting. Look at that. What does it say? All right, except for no, there's no 9 on the end of yours. Okay. Good job. Good job. Okay, here we go. Next one. I'm going to trick some of you guys on this one. Equation of that circle. Okay. All right. Jordan, where's the center of my circle? Center of my circle. What's the coordinates of the center of my circle? 0, -2, right? What's the radius of my circle? 4, right? Okay, good. Yeah, it's 4. You're right. Okay. Brooklyn, what's an equation for my circle? Okay, now, can I simplify this? What's x minus 0? It's just x. So I can write that as x squared, right? Y plus 2 squared. And 4 squared is 16. There's an equation of that circle, right? So whenever x is 0, you can just write x squared. Got that? Yep. Okay. See if you guys are paying attention right here. Find the equation of that circle. Okay, good, Johnny. X squared plus y squared equals 1. Because the center of the circle is 0, 0, right? So x minus 0 squared is just x squared. Y minus 0 is y, so y squared, and then 1 squared is 1. Guys got the idea? Okay, now we're going to do the opposite. Now I'm going to give you an equation and you have to graph it. Because another type of problems they give you on the test is to write something like this. And they'll want to know, and then they'll give you 4 graphs, and they'll say, which one is the graph of this circle? Yep, you're going to come up here and graph it. So I'm going to have, Mitchell, why don't you come up here and graph the first one? Mitchell, listen to your buddy. Wait. Actually, you're not in the right place. For your center of your circle. Think about it. Where's the center of the circle? Where's the center of the circle? But also, what about the 5? Which way? Jordan's showing the right way, yeah. Good job. Good job. Okay. All right, there's the perfect circle right there. Okay, so the center, you guys, was at 5, comma, -1. You guys all understand why that's -1, right? Because it was y minus a -1, right? And r is equal to 4. So we went to 5, comma, -1, went out 4 to draw our circle. Okay, next one. Hey, who wants to do this one? Haley, go ahead. Oh, I need a nap. What do you think? Is she right? Yep. Good job, Haley. Okay, so we went to -1, 8. Okay, and a radius of square root of 4 is 2. Got it? You guys think you can do those on the test? There's usually 4 or 5 questions on the CRT test with those. Let's do one more. Let's do this one. Okay, I would like to graph that one. Okay, go. Oh, who said that? I thought you said that, Jordan. Okay, Matt. I thought Jordan said he wanted to do it. I believe Matt's shirt is true. Okay, good job, Matt. Hey, wait. Let me see your shirt again. Hey, let me see your shirt again. I put the pro in procrastinate. All right. Good job. That's not what I was looking for. Okay, your assignment today. Can you do like 3? Lesson 14-6, page 620. Number 2. Number 14. Number 16. Number 22. Number 24. That's good. Okay, Matt and Mitchell, turn around right here. Okay, Johnny and Jordan. Okay, I'm going to talk right here. Oh, whoops. I forgot to start that. What point did I turn it off? Okay. The measure of an intercepted arc of an inscribed angle is twice the measure of the arc. So if this angle is 34 degrees, this intercepted arc is 2 times 34, which is 68. So right up here is 68. And up here, we have 172 degrees as our intercepted arc. Half of that is 86, and that's what the inscribed angle would be. So that will get you 1 or 2 questions on the CRT test. Make sure you review that. Okay. Sometimes they'll do something like this, you guys. You have this circle, and they might have something like this. Okay? And they want to know this intercepted arc out here. It might be something like 60 degrees. They want to know what X and Y are. Okay? Actually, that's exactly what Chris said. Whoops, they're both 30 degrees, aren't they? Well, yeah, they don't look it because I didn't draw it to scale, sorry. But the intercepted arc is 60, and these are the inscribed angles that make the intercepted arc. You got to look for inscribed angles in there because sometimes they're tricky to see. And they start drawing lots of lines. Anytime you see an angle coming down and hitting a vertex, or anywhere, like right here, like right up here, just follow the lines to where they intercept the arc and know that that's its intercepted arc, okay? They're kind of tricky. They try to trick you with them sometimes, so make sure you look for those. Okay? I got to say that one more time. I didn't have this on. Okay? If you have a 90-degree angle as an inscribed angle, its intercepted arc is twice that much, which is 180, and it makes a diameter going across. So it creates an intercepted arc that's a semicircle. How many of you know what a tangent line to a circle is? Do you know what it is, Lindsay? It touches the circle at one point, yep. Any tangent line is a line that touches a circle at one point. And there's some special things about a tangent line to a circle, okay? First thing is if you draw the radius to the point of tangency, and this is called a tangent line once again, and this is the radius to the point of tangency, it forms a special angle. What angle does it form between the tangent line and the radius, you guys? A 90-degree angle. Okay? It creates a 90-degree angle. Okay? Also, this is one other thing you need to know about tangent lines. If you have a circle and you have 2 tangent lines on the circle, like this one right here and one over here, and there's a point of tangency and there's a point of tangency, the distance from where these 2 lines intersect to the point of tangency on that one and that one are congruent, okay? Got it? So sometimes they do a problem like this. They'll put the center point right there, and they'll draw a point of tangency, point of tangency. What do you know about this angle right here? How much is this angle? It's 90 because it's a radius to a tangent line radius to a tangent line, you got two 90-degree angles. So if you know one angle, one of these two angles, you can find the other one. What do the four angles of a quadrilateral add up to? 360, because this makes quadrilateral. It makes a kite, as a matter of fact. Because you know that radiuses are congruent as well, right? Okay, so that's what you need to know about tangent. These are the first two sections. I just taught you the first two sections of chapter 14. So inscribed angles and tangent lines. Can you remember these things a little bit? Okay. And circles that touch are tangent circles. I don't know if you need to know that. I can't remember. If you have a bunch of circles that touch like this, these are called tangent circles. They're touching each other each at one point. Got it? Okay. The only thing I haven't taught you about is secant lines, and maybe I'll touch on that next time, okay? Hey, you guys, study this packet I gave you. Study the packet. Thanks.